All right. Hey guys, so this is going to be a quick run through of the content that we're going to be missing for the seventh graders that are on quarantine this week. So what I'm going to go through, I'm going to go through the notes that we would take in the interactive notebook. We're not going to get you guys interactive notebook cutouts in time for it to be worth your time. So you can just make sure to take the notes down for now, get them written down, and then when we get back, I can give you the pages if you really want to have it all set up like this. If you want to just write notes out by hand this week, that'll be good practice because we're going to go away from the interactive notebook as the year goes on anyway. But hopefully we can make it pretty clear what's going on. Some of these problems you won't be able to have like the whole problem there. Like I don't expect you to write out all of this text about Rita's family. We'll get to that in more detail soon. But just follow along, write out whatever notes you think are necessary, and we'll try to get you as caught up as possible, or keep you as caught up as possible while we're gone. Hopefully, at least the first round of kids that went out on quarantine, it sounds like are going to be back before our next quiz. But I know a lot of kids didn't get a chance to take the first quiz. We can't have these ones taken out off of campus. Calculators would make them all incredibly easy. It'd be super easy to cheat and get 100%. Not that I expect anybody to cheat, but we have to make sure that you're in here so that it's fair for everybody. So when you get back, we'll be making up whatever quizzes that you guys have missed. Hopefully it won't be more than one. So just make sure that you're as prepared for that as possible. We should have more information later in the week about how we're going to do classes going forward. But this video will cover all of the content that we're going to go over for this week in seventh grade math. So hopefully you guys can pause the video if you need to write something down. If you need to rewind to go a little slower, that's perfectly fine too. I'll try to take it at a reasonable speed, but I'm not gonna spend a ton of time waiting. So like if you're writing down the definition of a vocab word, just pause the video, give yourself a chance to get it written down and then move on. So we'll go ahead and jump into it. These are our targets. I'm not too worried about going through those. Basically, we're learning how to multiply and divide using negative numbers. And then we'll do a little bit of stuff with powers towards the end. So this would be an Explorer that we are going to do later in class. Actually, I'm saving this for the end of the week. It will be posted to Google Classroom probably tomorrow. It's basically something that you do using number lines. Since you guys can't draw number lines at home, I'm not going to expect it as an assignment from those of you that are on quarantine. It'll just be excused. But if you want to draw out number lines on a piece of paper and actually do this practice, it will be really helpful for you to get these concepts down. So I would strongly recommend it when we get to that. So starting with our vocabulary, the first thing we have is product. And a product is the solution to a multiplication operation. So basically, if you multiply two numbers, the answer to that problem is a product. So we'll use product a lot going forward as just kind of a general term for multiplication problems. So if I say, what's the product of 4 and 5? I'm asking you to multiply 4 and 5. That's just what that word means. And you guys can, like I said, pause the video here if you need more time to write this down, because I'm going to go kind of quick through the vocab. Quotient, that's the solution to a division operation. So it's the exact opposite. If I say, what's the quotient of 48 and 6? Hopefully you will be able to divide those out and tell me that the answer is 8. Inverse operations. Now we are going to work with inverse operations for a solid 3 weeks later in the year when we're doing an introduction to algebraic expressions. But inverse operations are just operations that undo each other. So for example, if you start with 3 and you add 3, you're going to have 6. And then if you subtract 3, you're left with 3 again. So the plus and the minus 3, those undo each other. So those are called inverse operations. So as you can see here, plus is if the standard operation is an addition, the inverse operation is subtraction. If you start with subtraction, the inverse is addition. Multiplication and division are also inverse to each other. So if you have a multiplication, you can divide to undo it. You have division, you can multiply to undo it. This one might be new to you guys, and it is something we're going to talk about a little bit in this unit. So if we have a number squared, the inverse of squaring a number is a square root. And by contrast, just like with the other ones, the inverse of a square root is a square. And that's something that we will talk more about as we get into algebra. A lot of the undoing squares you're going to do next year, and then especially in algebra 1. But just so you guys can start to see it now, we'll include that in there. So a power, this is used to express a product of a repeated factor. That's a fancy way of saying that a power is basically a thing that's being multiplied out by itself repeatedly. A base is the repeated factor, and an exponent is the number of the times the factor is repeated. So effectively, let's say we have this. Let's say we have 2 to the 5th. This is a power, and what it means is 2 times itself, a total of 5 times. So we have 1, 2, 3, 4, 5 2's, multiplying them all together. 2 to the 5th does not equal 2 times 5. This is a very common mistake that students tend to make. It will probably happen to you at least once throughout the year. That's okay, but we're going to try to work on remembering that if you have a number raised to an exponent or to a power, then it is multiplied by itself that many times. All right, the next vocab word is squared. So this is just a number taken to the second power. And the reason we call it this is because if you have a number, let's say we have the number, let's go with 6. And we build a square out of the number 6. This is not going to be a perfect square. My lines are going to be all gross. It's going to be a really bad square. If we build a square out of the 6, the area of this square is 6 times 6, 36. This is equal to 6 squared. So this is why we call a number raised to the second power squared. And then cubed, that's the number raised to the third power. Basically the same idea, but instead of being just a square, it's 3-dimensional. So the volume of the cube with a side length of, for example, 2 is going to be 2 times 2 times 2, or 8. All right. So getting to our first example. Now, multiplication rules, you guys don't have these in your interactive notebook because you don't have the interactive notebook. So what I'm going to do before we get too far into this is I'm going to make a little chart over here. And this chart is actually in your homework. So hint, hint, if you want to take the homework out, look at this. You'll be able to get a free answer here. But let's say I am multiplying the following. If I multiply a positive number times a positive number, my answer is always going to be positive. Now, you guys should already know that. You've done positive multiplication for most of your life. If you do something like 3 times 6, you should know that the answer is 18, and you don't even have to worry about a negative. There's no negatives involved. It's just positive 18. If we have a positive number times a negative number, so for example, let's say we have positive 2 times negative 4, this answer is going to be negative. So we're going to have negative 8. Then if we have a negative times a positive number, this is actually going to be the same idea. So let's say we have negative 7 times positive 5. Our answer here is going to be negative as well. We're going to have negative 35. So our answer is going to be negative. Where it gets really confusing is if you have a negative number times a negative number. So we have negative times a negative. The answer to a negative times a negative, so let's say we do negative 6 times negative 9. This is equal to positive 54. A negative times a negative is positive. And we're going to go over some examples really quick so I can kind of show you how this works on a number line. But I want you to be able to have this chart kind of down somewhere. So make sure you write this out. Now, this is for multiplication. I'll put multiplication up at the top. So if you're copying it down, you can make sure yours looks the same. But division, well, I can't spell. Division actually works the same way. So division, if you have a positive divided by a positive, again, you should already know that that's going to give you a positive answer. A positive divided by a negative gives you a negative answer. A negative divided by a positive gives you a negative answer, and a negative divided by a negative gives you a positive answer. So I'll redraw the table. We'll go in more detail. We'll go a little bit slower. But basically, if the signs are the same, the answer is positive. If the signs are different, then it's going to be negative. So I'll give you a second. If you want to get this table written down, you need more time, just pause the video here because I'm going to clear this out so we can go through this example problem that's on the board. So we've got 5 times negative 4, which we can read as 5 groups of negative 4. Remember, all multiplication is telling us how many times to add a number together. So 2 times 6 is the same as 6 plus 6. We add it together 2 times. 5 times negative 4 then is just negative 4 plus negative 4 plus negative 4 plus negative 4 5 times. So if we go onto a number line and we make jumps of negative 4, we're going to do 1, 2, 3, 4, 5 of these jumps. So we get to negative 20. And you'll notice since we're doing 5 groups. We have these 5 things over here, but all of them are going in the negative direction because we're adding -4. So this would be the same problem as -4 plus -4 plus -4 plus -4 plus -4. And now put parentheses on these so you guys can see it the way it would actually look on a problem. So again, if we were doing -4 plus -4, we would go, the sign tells us to go right, but since we're adding a negative, we go the opposite. So we go left 4 spaces, that brings us to -8. Then we go to -12, and then we go to -16, then -20. So the product, which is -20, is the same as if you have 5 times 4, and then you just throw the negative sign on top, right? So multiplying the numbers themselves doesn't change at all. It's just how do we deal with the sign? So 5 times -4 is equal to -20. -2 times -3. Now, the way you read these ones, and the reason that a negative times negative gives you a positive number, is because it is read as the opposite of 2 groups of -3. Now, negative signs in math are often used to mean opposite as well. It's a little bit of a pain. Whoever decided to have opposite, minus, and negative all be the same symbol probably shouldn't have been allowed to choose symbols for math, but that's what we're stuck with, so that's how we're going to learn it. But the opposite of 2 groups of -3. So what you can do is multiply it out like you're doing 2 groups of -3, and then just take the opposite of that number. So here, 2 groups of -3, we have our first group, we have our second group. First one brings us to -3, second one brings us to -6. So we're at -6, that would be 2 times -3, and then we just take the opposite, so +6. Now, it may be a little bit simpler for you to say, okay, negative times a negative is always positive. 2 times 3 is 6, so my answer is +6. And eventually that's the point you're going to get to. These number lines are just to help you visualize it if this is confusing. And everybody here is pretty new to negative, so it's probably a little bit tricky right at the start. So here's the actual steps for multiplying integers. You can write these down if you want to. Most of the kids have them in their interactive notebook. So if you want a printed copy of this when you get back to have before you take your quiz, I will let you have that. But you can also write it down. It might help you out doing the homework for this week. So the first step is to determine the sign of the answer. The product of 2 integers with the same sign is positive. So if you have a positive times a positive, your answer is positive. If you have a negative times a negative, your answer is positive. The product of 2 integers with different signs is negative. So if you have a positive times a negative, your answer is going to be negative. Also, if you have a negative times a positive, your answer is going to be negative. Then number 2, find the product of the absolute value of the numbers and use the sign determined above. So again, you're just figuring out what the sign is, multiply the numbers like you would normally, put your sign on. It's not too terrible. So here's a story problem example. We're going to look at this in a little bit more, or in depth. We'll see how we can model these and then how we can actually multiply them out. So this says that a submarine descends below the water surface at a rate of 50 meters per minute. Find the integer that represents the submarine's position relative to the surface of the water after 6 minutes. So basically, we're dropping 50 meters per minute, and we're going to do this 6 separate times. So our 50 meters is going to be negative, our 6 is going to be positive. Time can never really be negative unless you're talking. Time will almost never be negative. Let's not worry about that right now. So first we want to write the problem. This is 6 groups of -50. The integers have different signs, so your answer is going to be negative. You're multiplying a positive number and a negative number, your answer is going to be negative. Then we just multiply 6 and 50. 6 times 5 is 30. We add the 0 on, we get 300. So our answer should be -300. And if we want to write this out in text, the submarine is 300 meters below the surface of the water after 6 minutes. So hopefully not too terribly bad. Again, you're just figuring out what your sign is, multiply the numbers, put your sign on it. Easy peasy. Here's another multiplication example. Now, this one has 3 separate numbers. There are 2 different ways you can do this, and I want to show you both. So the first way, you can multiply the first 2 numbers, and then once you have a product from that, you can multiply that by the third number. So if we do this, 2 times -5, that's a positive number, times a negative number, our answer is going to be negative, and 2 times 5 is 10. So that leaves us -10. We multiply this by the -4. We have -10 times -4, that's a negative times a negative, so our answer is going to be positive. 4 times 10, that's 40. So our answer would be just 40. Now, the other way you can do this is you could actually figure out from the problem, you can figure out what the sign is going to be from just the start. Now, this might get a little bit confusing. So if you're just trying to figure this out, if you're struggling a little bit already, ignore this, maybe skip forward a little bit. But if not, I'm going to go through a trick that can tell you how to figure out the sign no matter how many numbers there are. So here we have a positive number times a negative number times a negative number. What you can do when you're doing this multiplication, so I'll put dots here to make sure we know it's multiplication, is you can just count the number of negatives. We have 1, 2 negatives. If the number of negatives is even, if you have an even number of negatives, your answer is positive. If you have an odd number of negatives, your answer is always going to be negative. So for our purposes, we usually only look at two numbers, which means if you have two negative signs, that's an even number of negatives. So your answer is positive. If we have just one negative, that's an odd number of negatives. Your answer is going to be negative. But this way you can tell what like if we have a positive number times a negative times a negative times a positive times a negative times a positive, we can figure out without even doing any math here that our answer is eventually going to be negative. We have 1, 2, 3 negative signs. That's an odd number. So our answer overall is going to be negative. That's just a little shortcut trick if you want to use it. Totally up to you. So this is the first way I was talking about. So we multiply the first two integers. 2 times -5 gives us -10. Then we multiply the product by the last integer, so -10 times -4, which gives us 40. So overall, 2 times -5 times -4 is 40. Now, dividing integers, this is basically the same idea. So first, we want to determine the sign of the answer. Then we want to find the quotient of the two numbers and then add the sign. So same exact thing as last time. I'm going to put a table up here in case you want to copy this into your notes. But it is the exact same as the one for multiplication. So for division, I may not have made this big enough, but that's okay. We'll make it work. Oh, this is not nearly big enough. So if we have a plus divided by a plus, our answer is going to be plus. So positive divided by positive, our answer is positive. If we have positive divided by negative, our answer is going to be negative. Negative divided by a positive, our answer is again going to be negative. If we have a negative divided by a negative, that just looks like a percent sign, but our answer is going to be positive. So exact same table as with the multiplication. Again, this is also in your homework, so you might want to go make sure you've got that part done. But if the signs are the same, the answer is positive. If the signs are different, the answer is negative. So looking at 40 divided by -5, if we look back at our little chart here, we have a positive divided by a negative, so that's here. Positive divided by negative, our answer is going to be negative. So our answer is going to be negative. 40 divided by 5 is 8, so our answer is -8. That would be a separate answer thing. So -8 is the answer to that problem. Let's look at another one. -20 divided by -2. You can go back to your table. We have a negative divided by a negative. That is going to be a positive number. So we know our answer is going to be positive. Then we just do 20 divided by 2, which gives us 10. So same signs, answer is positive. -20 divided by -2 gives us positive 10. Here's a story problem example. I don't expect you to write this one down. Maybe if you want to put the math in, you totally can, but that's up to you. So this says, Rita's family went hiking last weekend at Multnomah Falls. They walked to the top of the falls and then turned around and came back down. It took them 15 minutes to descend 600 feet in elevation. One integer represents their change in elevation each minute. So the first thing we have to do is write the problem. Now we have 600-foot descent, so that's -600. And we're dividing that into 15 different minute-long intervals. So we have -600 divided by 15. That's the first step. These integers have different signs. We have -600 divided by a +15. So negative divided by a positive, we know our answer is going to be negative. And then 15 goes into 64 times. There's an extra 0 left over, so we should get -40. So the family's elevation change is represented by -40 feet per minute. Or basically, they descended 40 feet every minute they were hiking. So again, if you want to play that back slower, you are welcome to. If you want to pause here so you can take this all down, that's fine too. But I'm going to go ahead and move on. Last thing we're going to look at is powers, bases, and exponents. And I already covered a little bit of these. You're going to do this a lot next year, but we'll have a little bit of it on this upcoming quiz here. So again, your base is this number at the bottom. This is the number being multiplied. That's the base. The exponent tells you how many times to multiply it. So This right here is what we call exponential form. It's when we have a number raised to a power, or a base raised to an exponent, however you want to call that. And then expanded form is when we actually have each of the numbers multiplied out individually. So 3 times 3 times 3 times 3. So if the base of a power is positive, the power of the positive, the value of the power will always be positive. So basically, if you have positive 2 to the 17th, it's going to be a positive number. If you have a positive base, your answer is always going to be positive. If the base of a power is negative, the value of the power will be positive if the exponent is an even number, negative if the exponent is an odd number. Now, this goes back to what I was talking about earlier. So let's say we have a negative number. I'm going to call it negative x. Now, let's say we raise it to the third power. Basically, what we have here is negative x times negative x times negative x. So we have 1, 2, 3 negatives. That's going to be a negative number. That's an odd number of negatives. Our answer is going to be negative. If we have negative x to the, let's say, 6th, we'd have a negative times 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 a negative. So we have 1, 2, 3, 4, 5, 6. That's an even number. So our answer is going to be positive. So negative times negative, this forms a positive. This forms a positive. And this forms a positive. And if you multiply 3 positive numbers, your answer is going to be positive. So that's basically the shorthand of how powers work. So to start off, we want to be able to write expressions as powers. So this is 5 times 5 times 5 times 5. The first thing you want to do is identify your base. So that's what number is being repeated. In this case, we have a 5 that's being multiplied multiple times. So our base is going to be 5. Pretty simple there. Then we need to figure out what our exponent's going to be. And in this case, all you have to do, you count out how many times we multiply it. So we have 1, 2, 3, 4, 5s. We've done this 4 times, which means our power is 4. So 5 times 5 times 5 times 5 is the same as 5 to the 4th. Negative 11 times negative 11. Our base here, since we've got 2 negative numbers, our base is going to be negative 11. And our power, since there's only 2 of them, is going to be 2. Now, when you're writing negative bases in exponents, you want to put them in parentheses and the exponent outside the parentheses, because that tells you to multiply the negative part multiple times. This negative 11 squared is actually different. Again, mathematicians are really bad at coming up with notation, so just when in doubt, put the parentheses around your negative number. It'll help make things a little bit easier. So this gives us negative 11 squared. And we should know from the last slide that our answer to that is going to be a positive number, since it is an even exponent. This one, we've got 7 times 7 times 7 times 7 times 7. So base should be pretty easy to identify. 7, we're using that number over and over again. And then, sorry, we can count the number of 7s. 1, 2, 3, 4, 5. So we know that our power is going to be a 5. Nope, the wrong way. Now, if we want to write each power in expanded form and then find its value, the first thing you want to do is just write out how many times you're going to have to multiply them. So 8 squared, that's 8 to the 2nd power. That's just 8 times 8, and 8 times 8 is 64. So this is the number in expanded notation. It's 8 times 8, and then 8 times 8, hopefully you guys know, is 64. And if not, you can always use calculator. Negative 1 to the 5th. So if we write this one out, we're going to have 5 negative 1s being multiplied by itself. Now, 1, no matter how many times you multiply it out, it's going to be 1, right? You can multiply 1 5,000 times. It's still going to be just 1. So we know our answer is going to be 1. We just need to figure out whether or not it's going to be positive or negative. So we look at our exponent. Since this is an odd exponent and we're using a negative base, our answer should be negative. So here's the whole thing written out in expanded form. I was too lazy to write that by hand, but there are 5 negative 1s here, and then our answer is going to be negative 1. So these 2 form a positive. These 2 form a positive. That leaves 1 left over. So our answer has to be negative. Positive times a positive gives us another positive. Positive times a negative leaves us negative. Last one, negative 4 to the 4th. So I told you that this is different. When the negative is not in a parentheses, this actually tells you to do a different thing. So this is a little bit confusing. That's why we put it in our notes. Now, I'm not going to trick you on the quiz. There's not going to be any problems that are like this, but this is an example of why you don't want to write things this way. So this is read the opposite of 4 to the 4th power. So what this is, you'll notice there's only one negative down here. And the reason for that is actually order of operations, which we're going to talk about in a lot of detail next week, but hopefully you remember them a little bit. So PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. Now, exponents here comes before multiplication, and a negative sign in front of a 4 is basically the same thing as -1 times 4. So what this is doing is -1 times 4 to the 4th. Now, again, super confusing. Why did mathematicians decide to do this? I don't know. Probably just to make 7th graders stress a bunch, but hopefully we can get this down. So basically, this is a warning. If you want to raise a negative power or a negative base to a power, you need to put it in parentheses. Otherwise, it tells you to do this. Just put the negative on the outside, multiply all the numbers, and just make your answer negative no matter what. So in this case, we would have -256 when we multiplied this out. And that's the end of the content for this week. So in the Google Classroom, probably tomorrow morning, all the assignments are going to be posted. So we have some IXLs this week. They are highlighted in there. There should be like, actually, hold on. I want to make sure because some of them are required, some of them are not. So give me just a second. Okay, so 17, 20, and 22. Okay. And they are in C. So C17, C20, and C22, these are all required. So the ones I'm circling right now, these are the required IXLs for this week. There's going to be an assignment that tells you what to do for these. For this week, since so many of you are in quarantine and those little rubric sheets are really hard to edit when we're online, I just want you to go to at least 70 on each of these. And we have some optional ones. So I strongly encourage you guys, since you're on quarantine, to use these optional ones. They're going to give you extra practice. Those ones are also highlighted, but let me check. Let's see. So 16, 18, and 21, it looks like. So the optional ones are C16, C18, and C21. These are optional. They're not going to give you any points or anything, but they are going to help you understand this stuff better. So it might be a good idea to run through them, maybe just check a couple problems on them, make sure you know what you're doing. Those can be helpful. And obviously, since they're lower numbers, hopefully you would guess. If you're struggling with C17, try C16 first. If you're struggling with C20, try C18 first. If you're struggling 22, try 21 first. There are also going to be one practice, that number jumping explorer that I talked about earlier. That one's going to be excused for everybody online because I don't really have a good way for you to do it. I would strongly recommend using a piece of paper on your own and actually writing it out and trying it on your own anyway, because it's going to be good practice for you. But since we only had 3 days this week for the kids that even were in person, because the quiz was on Monday, we're not going through a whole lot more than this. So hopefully it won't be too bad for you. Next week, we'll have a more stable idea of how we're going to teach with so many kids on quarantine. But we will let you know about that in a post on the Google Classroom. So hopefully you guys are taking care and doing all right. That's all I've got for this one today, though. So I will see you all later.